We are going to solve question number 29, part A. So, question number 29, part A, then we have to integrate. Let's say our integral is I is equal to integration of cos x by sine 3x. Okay, and for this, let's try to simplify this. And we know that sine 3x formula. So, sine 3x is equal to 3 sine x minus 4 sine cube x. So let's replace this here, and our integral is I is equal to cos of x upon 3 sine x minus 4 sine cube x into dx. Okay, now it's ready for the substitution because we know the differentiation of sine is cos. So let's substitute sine x. So sine x is equal to d, and differentiation of sine x is cos x. Differentiation of x is dx by dt. I am going to write dx here and shift dt to that side. Differentiation of t is 1. So let's make the substitution and get our integral in terms of t. So cos x into dx is dt. 3 sine x is 3t minus 4 sine cube. Okay, this is not 4 sine cube t. This is sine is t, so this is 4t cube. And it has to be further simplified. For this, let's take t cube common. So if I take t cube common here, so taking t cube common means we have to divide each and every term by t cube. So this is 3 by t square minus 4 and dt. Okay, now we can make another substitution because the differentiation of t square is gives us t cube. So let's say 3 upon t squared minus 4 is equal to z. 3 is constant, and differentiation of 1 by t square is minus 2 upon t cube. Differentiation of 4 is 0. So this is, we are differentiating this with respect to z. So this is dt and this is dz. Okay, this is dz by dt. This is dz and dz by dt. Okay, differentiation of z is 1. So finally we have minus 6 upon t cube into dz is equal to dt, which gives us dz upon t cube is equal to minus dt by 6. Let's make the substitution. So this dt upon t cube is minus 6. Minus 6 minus, look at this, is we have differentiated this with respect to z. So this is dz by dt, and dz by d cube is equal to minus dt by 6. So this is actually, we have differentiated this. So this is dt by dz, and dt is equal to z dz. So this is dt upon t cube is equal to minus 1 by 6 dz. So dt upon d cube is equal to minus 1 by 6. So dt by t cube is minus dz by 6. And let's make the substitution. So I is equal to minus 1 by 6 is out. This dz, and t cube is also included, and this 3t square minus 4 is z, which is equal to minus 1 by 6 log z plus c. And let's replace the value of z, which was 3 upon t square minus 4 plus c, and let's replace the value of t. T was sine x. So this is sine square x minus 4 plus c, and sine square x is 1 upon sine square x is cosecant square. So this is 3 cosecant square x minus 4 plus c. So I is equal to minus 1 by 6 log 3 cosecant square x minus 4 plus c is the answer for the part A. Let's move on to part B, for which we have to find the integral once again. And for that, let me remove this. Okay. Now, for question number 29, part B, our integral is, let's say, I is equal to x squared. So this is the product of two functions, log of x squared plus 1 into dx. This is u and this is v, and we are going to use integration by parts. And for using integration by parts, let's put them in order using ILATE. So algebra log is the first function, so this is the first function, and algebra x square is the second function. So I is equal to, this is log of x square plus 1 into x square into dx. And now we are going to use using integration by parts. We get I is equal to, so integration by parts says that it's the first function into integration of second function minus integration of differentiation of first function into integration of second function. The whole has to be differentiated. Okay, this is now I is equal to log of x squared plus 1, and integration of x squared is x cubed by 3. Differentiation of x squared is 2x into its x cubed by 3. Okay, this has to be differentiation of log. The first function is differentiation of log of x squared plus 1. And integration of x squared into dx. Okay, so differentiation of log of x squared plus 1 is 1 upon x squared plus 1, and differentiation of x squared is 2x into integration of x squared is x cubed by 3 into dx. Okay, so I is equal to, now this is x cubed by 3 into log of x squared plus 1. 2 and 3 are constant, so this is out, minus 2 by 3, and we are left with integration of x raised to power 4 upon x squared plus 1 into dx. Okay, now this is an improper function where the degree of the numerator, that is x raised to power 4, it has degree 4, this has degree 2, so we are going to divide and convert this into the proper form. So let's divide x raised to power 4 with x squared plus 1, so this is x squared, and x raised to power 4 minus x squared, and this gets cancelled, so this is x squared. So okay, so this is positive and it has to be negative. This is negative, so it's negative x squared, so it's minus 1, and it's minus x squared minus 1, so let's subtract them, which gives us 1. So this integration, I can write it as I is equal to x cubed upon 3 into log of x squared plus 1 minus 2 by 3 And instead of x raised power 4 by x squared plus 1, I can write x squared minus 1 plus 1 upon x squared plus 1 into dx. Okay, now we have three different terms, and now it's easy to integrate. So I is equal to x cubed by 3 into log of x squared plus 1 minus 2 by 3. Integration of x squared is x cubed by 3. Integration of minus 1 is minus x. And this is integration of 1 upon x squared plus 1 is tan inverse x plus c. So this is our answer, and if you want you can also expand it. So this is x cubed upon 3 into log of x squared plus 1. So this is minus 2 x cubed by 9 plus 2x by 3 minus 2 by 3. This is minus 2 by 3 tan inverse x plus c. Okay, and this solves our question number minus 2 by 9x cubed plus 2x by 3 minus 2 by 3 tan inverse x plus c. And this solves our question number 29. Let's move on to question number 30.